Welcome to this elementary statistics lesson on the binomial distribution. In this lesson, you will learn the definition of a binomial experiment, how to calculate binomial distribution parameters, and how to calculate binomial probability. A binomial distribution is the distribution of results of a binomial experiment. A binomial experiment consists of n repeated trials, each of which can have one of two possible outcomes, success or failure. The probability of success and failure is equal in every trial, and the trials are independent. That is, the outcomes do not influence each other. A binomial random variable is the number of successes, x, in some number of trials, n, in a binomial experiment. Let's consider an example. Pulling marbles from an urn of red and blue marbles. This is a binomial random variable. The binomial random variable here is the number of marbles of a certain color in n experiments with replacement. A trial is pulling a marble from an urn. Success in this case we'll define as pulling a red marble. Failure we'll define as pulling a blue marble. We'll have 10 trials in this binomial experiment. Is the probability the same on every trial? Yes, it is, because we're trialing with replacement, meaning that we'll put whatever marble we pulled back in the urn. The mean of the binomial distribution can be calculated. The mean of the distribution, or mu of x, is equal to n times p, where p is the probability of success on an individual trial and n is the number of trials. Let's consider an experiment. In this case, we have an urn of red and blue marbles. Let's imagine that we have 40 red marbles and 60 blue marbles. We'll do 10 trials, and the criteria for success will be pulling a red marble. The probability of success for a trial with replacement, p of red, is equal to 40 divided by 100 total marbles, because there are 40 red marbles. Thus, the probability is equal to 0.4. Given the equation for the mean described above, and the fact that we're doing n trials, the mean of the distribution is equal to n times p, the probability, or 10 times 0.4. The result is 4. In 10 trials of this experiment, an average of 4 of the results will be red marbles. This is the mean or expected value of the binomial distribution for this experiment. We can also calculate the variance of the binomial distribution. The variance of the distribution, sigma squared sub x, is equal to n, the number of trials, times p, the probability of success, times 1 minus p, or the probability of failure. The standard deviation of the distribution is the square root of the variance. Let's go back to our earlier experiment and calculate the variance and standard deviation. Recall that we have 40 red marbles, 60 blue marbles, and we'll be doing 10 trials. Success is a red marble. Thus, the probability of success for a trial with replacement, p of red, is equal to 0.4. So we calculate the variance by multiplying the number of trials, 10, by the probability of success, 0.4, by the probability of failure, 1 minus 0.4, the probability of success, by the subtraction rule, and we obtain 2.4. So the variance for the distribution is 2.4. The standard deviation is the square root of the variance, so we take the square root of 2.4 to find the standard deviation is equal to 1.5. This is the average distance from the mean of the distribution for the result of the experiment. Let's consider binomial probability. The binomial probability is the probability that a binomial experiment will result in x successes. For discrete distributions, it is possible to calculate this value. The formula for binomial probability is denoted b of x given n and p. That is, the probability of getting x successes in n trials with a probability p of success. This is equal to sub n c sub x, which is the number of combinations of n items taken x at a time, calculated using the combinations rule. You can go to module 5 to find out more about this rule. Sub n c sub x is multiplied by the probability of success raised to the x power, that is, the number of successes of interest, times 1 minus p raised to the n minus x power. Let's look at an example. Again, we'll return to our urn of 40 red marbles, 60 blue marbles, and our experiment of 10 trials with the success being equivalent to having a red marble. Let's use the binomial probability formula to determine the probability of pulling 7 red marbles in 10 trials. Recall that the probability of success for a trial with a replacement, P of red, is equal to 0.4 because there are 40 red marbles out of a total of 100. In this case, we're interested in having x equal to 7, that is, x equal to 7 successes, in n equal to 10 trials. First, calculate the number of combinations of n items taken x at a time using the combinations rule. Sub n c sub x is equal to n factorial divided by the product of x factorial and n minus x factorial, or 10 factorial divided by the product of 7 factorial and 10 minus 7, or 3 factorial. This gives a value of 120. Plug this value into the equation for the binomial probability. The binomial probability of 7 successes in 10 trials, given a 40% probability of success, is thus equal to 120, or sub n c sub x, times 0.4, the probability, raised to the x power, 7, multiplied by 1 minus 0.4, the probability of failure, raised to 10 minus 7, or n minus x, and this gives a probability of 0.006, or 0.6%. Thus, the probability of obtaining 7 successes in 10 trials is 0.6%. It's very unlikely. Let's summarize. Today we've learned that the binomial distribution is the probability distribution of a binomial random variable. The random variable is the number of successes, x, and some number of n trials of a binomial experiment, which consists of n repeated trials having one of 2 possible outcomes, success or failure, and an equal probability of success or failure in every trial. The equations for the key properties of the binomial distribution are shown here. These properties are in the mean, variance, and standard deviation. The binomial probability can also be calculated for the probability that the binomial experiment will result in x successes. For discrete distributions, which the binomial distribution is, because it can have only 2 possible values, it's possible to calculate this probability for a given value of successes. It is not necessary to memorize the binomial probability equation. However, you should understand how to use it. The combinations rule is employed in calculating the binomial probability, and this can be reviewed by returning to Module 5, the Counting Rules video, or the written chapters. Welcome to this elementary statistics lesson on the binomial distribution. In this lesson, you will learn the definition of a binomial experiment, how to calculate binomial distribution parameters, and how to calculate binomial probability. A binomial distribution is the distribution of results of a binomial experiment. A binomial experiment consists of n repeated trials, each of which can have one of 2 possible outcomes, success or failure. The probability of success and failure is equal in every trial, and the trials are independent. That is, the outcomes do not influence each other. A binomial random variable is the number of successes, x, in some number of trials, n, in a binomial experiment.